This is Greg Troutwine with Offshore Engineer TV. We're here in Houston at the OT 2026, and we're very pleased to be joined by Pierre Gazul of Tronics Microsystems to discuss an amazing array of technology that help these companies work more efficiently underwater. Just to start us off, can you give us just an overview of Tronics Microsystems and your offer to the offshore industry?
Sure. So Tronics Microsystems is a TDK group company, and we especially focus on high-performance inertial sensors, and mostly for demanding applications, transportation, avionics, and obviously the oil and gas industry, where we provide sensor solution mostly for directional drilling technologies.
So I know you have a pair of technologies here, one the accelerometer, another the gyro. The accelerometer we've obviously discussed before. Why don't you just give us an overview of the accelerometer, the technology, and where you find it in use today in the offshore energy industry?
Sure. So you're perfectly right. So once again, the mission of Tronics is to enable positioning and navigation systems. And when you drill, actually, you need to position and guide the drilling tool downhole. So the sensors that we have are both the accelerometer and the gyros are intended to guide downhole tool during the drilling phase. And to do that, you need two kind of sensors, as you mentioned, the accelerometer first and the gyroscope. So the accelerometer is used to measure the inclination of the tool, and the gyroscope is used to determine what we call the azimuth, meaning where you are going versus the north, so the direction of the tool. So one for inclination and the other for the direction. So we introduced the accelerometer this year. So this is a high temperature accelerometer, which is graded up to 175 degrees. And the accelerometer is able to measure the inclination of the tool with very high accuracy, even when it is exposed to very high temperature and vibration level. And this is the purpose of the demo we have on the booth today, being able to prove that the inclination measurement remains very stable even when we apply a very high level of vibration on the accelerometer, which corresponds to what's actually encountered downhole.
When you look at this, I mean, what was the impetus to introduce it? Because it just got introduced this year. And I guess, how is it differentiated on the marketplace? What does it do that others can't?
Actually, so far, the reference technology for inclination measurement in the oil and gas industry was what we call the quartz accelerometers, which is an excellent technology, but it tends to be a bit old. It's mostly analog technology. You need to add a lot of bunch on top of the sensor itself to make it usable in the system. Our technology is fully digital. So it means that from a system perspective, you can get rid of a significant number of components at system level because you get the digital data right out of these sensors. So you can remove complex function of the system. In addition, the form factor is much more reduced compared to quartz accelerometer. So yeah, it's a bit more, I would say, modern technology compared to legacy technology that we had on the market so far. And when it comes to the MEMS technology, which is at the core of our sensor, there are also some alternatives on the market based on MEMS, but they tend to suffer from, let's say, an accuracy that will degrade when exposed to vibration. And we have a special technology for that we call the closed loop technology, which helps the sensor remaining stable even under vibration. So that's the way we position on the market versus the competition.
No, that's spectacular. I know we talked about the accelerometer in a previous interview. Why don't we take a deeper dive into the gyro? Because like you said, you got to know where you're going. So why don't you discuss specifically the gyro product and what makes it unique to this market?
So this is the same story of providing something which is very small to the system makers, because you can find very good gyros with different technologies like fiber optic gyro or mechanical gyro, but they are very expensive, they are bulky, and at the end of the day, sometimes it's hard to fit them into downhole tool. So what we do provide with our new gyro is something which is very small, 12 by 12 millimeters, so very, very small. And that provides the same amount of performance compared to other technology like fiber optic gyro, which are that big and that cannot fit into downhole tool. So we get the performance, we get the accuracy, and we got, I would say, the miniature size and the digital output, which at the end of the day helps the system makers finding a, I would say, low swap alternative to other technologies on the market. We got a very good traction so far from the market. We have already some key customers evaluating that technology, especially, as I said, to replace different technology which are not so easy to use in their system. So yeah, we are very excited about it. It will hit the market in July this year. We will start pre-production of this gyro. And yeah, that's great news for the company because it comes as a companion chip of the accelerometer, and providing both to our users is a way to enable, I would say, a 100% MEMS-based technology inside directional drilling tools. So we are very excited about it.
No, that's amazing. So, I appreciate your time. Really, just one more question. You're an advanced technology company. Can you just, I guess, look at Tronics Microsystems in the whole and just discuss how you develop or deliver technologies to make offshore oil and gas exploration more efficient, more safe, more effective?
Yeah, so we come from, I would say, demanding application like aerospace, train transportation as well, which are also very demanding in terms of safety, in terms of accuracy, in terms of repeatability. Because when you have sensors in a plane or in a train, it has to work, it has to be reliable. And the environment is key, because when you're in a train or in a plane, there are fast changing temperatures, there are vibration as well. So going to the oil and gas market was a kind of continuation of our story, serving demanding application. We just needed to add the very high temperature, which is definitely new with the oil and gas market. But yeah, that's the story. We began with train and planes, and then we pushed the temperature limit up to 175 to address the energy market.